This video covers week 4 task 2 notes. This is going to be page 1. So the first video is going to be about growth. The second video is going to be about decay. So please make sure you watch both videos. So exponential growth occurs when a quantity increases by the same factor over equal intervals of time. So when you're going up and up and up and up and up every single time, over and over, okay? So exponential growth is represented by this formula. Remember what we talked about in task 1 looks like this, a times b to the x. So here, a still exists, right? B still exists. B is just going to be written a little differently. And then x is still b raised to the x. So it looks very similar. It just has a couple extra goodies for us, okay? So the first thing you need to notice is your y value is going to be your final amount. So this is going to be where you end, okay? You're going to do all this work over here and end up with an answer, okay? A is your starting, okay? So this is where you start here. Start at the y value first. And then we always take 1 plus our rate as a decimal, okay? So I'm going to put Beyonce. You're going to get it in a little bit, but that's where we figure out our R value. And then X is represented as time. So this first example, a population of 100 frogs increases by 20% every year. First, they want us to write an exponential function that represents the number of frogs y after x years. So we don't know our y value. I'm starting with 100 frogs. Then I have 1 plus my rate. Now remember, this rate has to be written as a decimal. So to get it there, we Beyonce it, okay? Beyonce has a song that some people think is about a relationship, but is actually a hidden message about math. Now she doesn't want to admit it because she feels like it'd be too nerdy, but Beyonce and I actually, we talk frequently, and so you can trust me on this. So that song that she wrote goes to the left, and it's actually a song about decimals. But remember, don't tell too many people because she doesn't want it to be well known that she actually likes math. So sometimes you might see your equations written as a simplified version like this, where they added the 1 plus 0.2 to simplify it to 1.2, okay? So how many frogs will there be in 5 years? So they are wanting us to solve for y when given 5. Remember, x is time, so 5 years is a 5 on my x value, okay? So I'm going to plug this into my calculator. So 100 times 1.2 raised to the 5. So I get 248.832. Now we know that when we're talking population, so alive frogs, we can't have 0.832. So we're just going to go ahead and round that to 249 frogs. Okay, and then they want a quick sketch. This doesn't have to be anything fancy. We know in the first year that there are 100 frogs. At 5 years, there's about 250 frogs, and then we know that exponential functions will go up like that. So one more example to show you for exponential growth. Example 2, everyone loves talking about money. Your starting salary at this company is $30,000. The company awards an annual increase, so we're going up. We're increasing of 4.5%. You started at the company in 2005. So they want us to write an exponential function that represents your salary y after x years. So again, rewriting at first. So we start with $30,000, right? That's your starting salary, so starting value. 1 plus my decimal. Remember, even though it has a decimal, I have 2%, so I have to move it to the left. Oh, cute. To the left. So that would be 0.045 raised to the x, okay? You might want to rewrite it just for the sake of plugging it into the calculator. 1 plus 0.045 is written as 1.045 to the x. Now, what will your salary be in 2015? So 2015 is an amount of years. Now, something important to note is they told us we started the company in 2005. So the time from 2005 to 2015 is 10 years. So in the calculator, we're going to use 10 for our X value. So it's going to look like that. 30,000 times 1.045 to the 10. So 30,000, 1.045 raised to the 10. And so after 10 years, now we're talking money, so we'll do two numbers after the decimal, 46,589.80. So 46,589. Yeah. Oops. 589.80. And again, dollar signs there because we're talking money. Then they want to know, when will your salary be more than $60,000? So the easiest way that you can do to solve this problem is to put in y equals 30,000, 1.045 to the x, and then use the table function to go find that value. So y equals 30,000, 1.045 raised to the x, and then second table, I'm going to scroll until my y values, until my, what is happening? How can I be getting bigger both ways? Okay, there we go. So sorry. Super glitchy. Kind of like School G. So at 16 x's, you notice at 15, we're almost at 60,000. So right here, I'll put it at the very top for you. That is the first time we get over $60,000. So that would be 16 years. Okay, so when you're working backwards, you want to plug your equation into y equals